In addition to what we've covered in relationship to dimensional analysis in terms of these types of conversions, one of the other things we have to understand is something that we refer to as significant figures. Now here's a pretty simple example of this, and I'll expand it just a little bit. And you're going to deal with this again when you deal with your chemistry class and your physics class. Essentially what significant figures are is identifying how accurate a measurement is, from the standpoint of we have these really cool calculators and computers, okay? And these calculators and computers, I mean, you can set them that depending on the screen size, they can deliver to you a huge number of numbers from the standpoint of, all right, when I do a math problem, show me 12 digits. And so you can, for example, the one we're showing here is, let's say we're asking the question, what is 1/7 of a foot? And a foot is 12 inches. So if we take 12 inches, if we take our really cool HP, reverse logic, whatever calculator, okay, whatever calculator we have, TI, whatever model, okay, we're able to afford or find online. Okay, well, afford by finding online, how's that? And we're going to take that 12 inches, and we're going to take 12 and divide it by 7. And notice, here's what I get out of my calculator. 1.71428571428, okay, and so on. Notice it repeats. 71428571428, 7142857, and so on and so on and so on. Okay, well, that's what your calculator kicks out. But if we look at those digits, and like we've discussed earlier, each one of those digits represents a value. A ones digit, a tens digit, a hundreds digit, a tenths, a hundredths, a thousandths, a 10,000th. Okay, you got to get that for the decimal after the decimal. You got to get that on the end. Okay, but each one represents something. Well, if I take a ruler and I'm measuring something, well, there's only a certain amount of accuracy that that ruler provides me. Okay, you may have a ruler that only gives you inches. You may have a ruler that's broken up in quarters of an inch. You may have a ruler that's broken up into eighths of an inch or sixteenths of an inch. Okay, things get pretty narrow. Okay, when you're starting to talk about 30/2 of an inch. And I've never seen a ruler that does 64ths of an inch or anything crazy like that. So in other words, that ruler only gives you a certain amount of accuracy. And so if you only measured in your research project, if you only measured using a ruler that had quarters of an inch, well, even though you stuck it in your calculator, you can't report this. You're reporting a level of accuracy for which you didn't measure. Okay, so if you had your test subjects get on a scale, and that scale basically is a pound scale, and it shows you pounds and maybe shows you quarters of a pound or half a pound or something, you can report the pounds and you can estimate, okay, so you can say, you know, person weighed, 174 pounds, like 0.5, 174.5 pounds, because it was right about the middle. You can estimate that last piece, but that's as far as you can report, because that's as good as your instrument is. Okay, for example, in our clinical chemistry department here, they have a scale that's kind of encased in glass, because just the movement of air from the heating and air conditioning will fluctuate that scale, because it measures in thousandths of a gram when they're trying to measure some of the chemicals they use in their class. And so they have a little dish that's in there, and they zero it, and then they start adding their chemical, and they shut the door and they wait, okay, for it to measure the exact down to thousandths, okay, of a gram. And so it depends on the accuracy of whatever it is you're measuring. So again, we can't measure this, or better said, we can with our calculator, but we can't report this because we don't have rulers that are that accurate, because we have the tenths and the hundredths and the thousandths and the 10,000ths and the 100,000ths and the millionth, and you get the idea. So we have to say, well, what accuracy can we report? Well, that's what significant figures are. Of this number I've got, how many of those digits are really significant? Therefore, what can I truly report? And there's rules for this, that basically, if any digit that's 1 through 9, any digit that's 1 through 9, not any number that's 1 through 9, any digit, okay, so you got 1, 2, 3, 4, 5, 6, 7, 8, 9, those are significant. So if I look at this calculation, okay, and I look at it and say, well, in this number I used in my calculation, there are 2 digits here, and they are significant digits. And over here, because there's a decimal there, that means that I did measure it to this accuracy. So 7.00, there's 3 digits there that are important. So the thing that makes this a little problematic are the zeros, for crying out loud. Okay? And so I'll mention the rules a little bit. And then in lab, you'll kind of go over the rules. But, so I have 2 measurements here. I have the 12 inches, and I have the 7.00. The 12 has 2 digits that are significant. The 7.00 has 3 digits that are significant. So the question is, when I report this, do I report using 2 digits or do I report using 3 digits? Well, the answer to that is you have to use the number of digits from the least accurate, or the least specific, the least precise number. So in this case, the one that has the least number of significant figures. So in this case, that would be 2 because of this number 12. There are 2 digits that are significant. So when I report this 1.7142857142855, I have to report it to the least number of significant figures. So I use 2. Okay, so I would report as 1.7. Now that last digit, of course, you would employ rounding rules, but 1.7, because I can't report with greater accuracy than was involved in my calculation, even though my really cool calculator kind of brought this out. Now, kind of as a case in point, you can't create digits where there are none. So in my calculation, I've got 1 significant figure in this number, I got 1 in this number, I got 3 in this. So when I put this on my calculator, okay, and it gives me 1.97, well, the accuracy of my calculation can only be as great as the number of significant figures in the calculation. So really, without tweaking these numbers, that's as accurate as I can report. Okay, is 1 digit, because that's what went into my calculation. So the general rule on these, I'm going to go back to the previous slide, the general rule on these is all of the digits that are non-zeros, so 1 through 9, they're significant. So however many of those you got, okay, those are significant. When you have zeros, that's when it gets a little bit hairy, and I mentioned one here, that if you have a whole bunch of zeros, and they are zeros in front of the number and there's not a decimal, those are simply placeholders, and so therefore they're not significant. If there's zeros within a number, so let's say you had the number 390,089. Okay, let me write that so you can visualize that a little bit. Well, let me get this piece of paper out of the way. So if you had, and I don't remember now which number I chose, but anyway, 390,089. Because these do have values within that number. It gives us what that number is. These are significant. So if this was my number, I have 1, 2, 3, 4 digits that are between 1 and 9, or non-zeros. So those are significant. And because these are confined within that number and actually have value, these are significant as well. So in this case, I have 6 significant figures, okay, that are in that number. Okay, if I have trailing zeros, like in the previous example, if I had 700, okay, that would only have 1 significant figure unless I said, hey, I had this much accuracy in my measurement. And so in that case, I would have, because the decimals are there, then I have 5 significant figures. So there are some rules to this. Okay? But basically what you want to understand of this is how many in the process, how many of these things can I report, because I only have a given amount of accuracy that I can report, because I only had a given amount of accuracy which I measured. So doing research projects and things of that nature, it becomes very important, okay, in that process. So be familiar with those, and of course some of your other science classes, you're going to get beat up with them as well.